Hi guys, Marketa here. We're now going to look at determining linear equations. So we're kind of working backwards here. They're giving us the graph and they want us to tell them what the equation is that was used to get that graph. So there's a couple of examples we'll work through here. The first is where they actually give us a graph, a picture of a graph, and they say, what's the equation of this graph? Now this one, we've got a number of points. We've got 6, 0, so that's an x-intercept because y is 0. We've got 0, 6, that's a y-intercept because x is 0. We've got negative 3, 9, and we've got 9 and negative 3. There are infinitely many points that are on a straight line graph, but you only need 2 in order to work out what the equation is. Let's see how we do that. So first of all, let's state the form. That's often what we need to do. Y equals mx plus c. Then let's identify the y-intercept. That's really easy because there it is there circled in red. The y-intercept is 0, 6. So it's at 6. Our c value, which is the y-intercept, must be 6. So now our equation is y equals mx plus 6. We now still need m. M is not the x-intercept. It is not any of the x values that we can get from the graph. It is the slope. Think about whether it's going to be negative or positive, because then when you get your answer, you have an idea whether you're right or not. In this one, it's going to be negative, because from left or right, it would be like you were going down a hill. So let's find what that m value is. In other words, what is the gradient? Our formula for gradient is rise over run. So what I'm going to do, I'm going to say, well, how do I get from my y-intercept to another point on the graph? I'm going to take the x-intercept as my other point. So from the point 6 on my y-axis, I need to go down 6. That means negative 6 is my rise. I put that in the numerator. Then I need to go 6 across in the positive direction of the x-axis, and that's where my point lies. So my run, or my horizontal distance, is positive 6 units. So that gives me negative 6 over positive 6, which equals negative 1. My gradient is negative 1. Once I know this, I can easily state the equation. I know c is 6, and I know m is negative 1. So y equals negative 1x plus 6. We don't need the 1, we can just say y equals negative x plus 6. Let's look at a different type. This time, they're telling us to find the equation of the straight line that passes through the points negative 2, 5 and 1, negative 1. They're giving us 2 points. They're not telling us the gradient, they're not telling us the y-intercept. So let's state the general equation as per usual. Y equals mx plus c. We're going to find the gradient, and we've got a formula for that. That formula is, the gradient is y2 minus y1 over x2 minus x1. When we have our 2 points, one of those points we could say is point 1 and one is point 2. I'm going to say that negative 2, 5 is point 1. So x1 is negative 2 and y1 is 5. I'm going to say that 1, negative 1 is point 2. Therefore, x2 is 1 and y2 is negative 1. So, negative 1 minus 5 is y2 minus y1, and x2 minus x1 is 1 minus minus 2. So 2 negatives in a row make a positive. So it becomes 1 plus 2. Negative 6 over 3 equals negative 2. M is negative 2. Let's now find the y-intercept. I know that my equation is now y equals negative 2x plus c. I got the negative 2 from the gradient. M is the gradient. C is still unknown. At this stage we have 3 variables, y, x and c. We can't solve because there are 3 variables. That's too many. We need 1 variable. We have information that when x is negative 2, y is 5, and when x is 1, y is negative 1. If we substitute that in, one of those points, we're going to be able to solve for c. So I'm going to choose to substitute 1 and negative 1. So y is negative 1. So negative 1 equals negative 2 times x is now 1, plus c. Negative 1 equals negative 2 plus c. Take the negative 2 over the other side, and we get c equals 1. We now know m and c, so we can easily state the equation, and that is y equals negative 2x plus 1. Let's now look at one where they give us a point and they give us the gradient. Find the equation of the straight line that passes through the points, or the point 5, negative 1, and has a gradient of 3. Let's state the general equation as per usual. Y equals mx plus c. Let's plug in the gradient. Y equals 3x plus c. Let's now find the y-intercept in the same way we did last time, by substituting in a point. This time they only give us 1 point. So that's easy, we don't have the choice, we just use that. When x is 5, y is negative 1. So y, being negative 1, equals 3x, because 3 is the gradient. X is now 5, so 3 times 5 plus c. Negative 1 equals 15 plus c. And c, therefore, is negative 16. We have m and we have c. So we have enough information to state the equation. Y equals 3x minus 16. Let's now look at how we would sketch these on our CAS. So when you turn on your calculator with the on-off button, you get to this screen here. This is the menu, and this shows you all the things you can do using your CAS. There's main, which is where you do your simple calculations. There's graphs and tables, which is where we're going to go. There's number solve, geometry, 3D graphs, etc. Lots of different functions there. We're going to go to graphs and tables. There it is there. Use the stick, or I think it's called a stylus, to tap that. By the way, the stylus is located when if you on the side of your calculator, if you look on the side, you'll see it's got a little place there. Don't lose it. When you click on graphs and tables, it takes you to this. By clicking on keyboard, there it is down there as one of the actual buttons, you get that thing at the bottom where it's got the numbers and the trig, the calc, option, variable, exe, all this stuff. Without that, you don't have that. You would probably have like a graph shown in there. So press keyboard so you get to that. Once you've got there, you can then type in your equation. So in the y1, put your cursor there and type 3x, there's the x there, plus 7. When you press exe, this one will turn black and this will be listed in the way that it should be written. So especially where you've got fractions and stuff, just check that what's listed, what's showing there is the same as what the actual question is. Be careful of BODMAS. Make sure that you have a tick in the box next to the graph and to the equation we want to graph. There it is there. And there's our exe button. We then click on that thing there. This is the graph function. When you click that, it takes you to the actual graph. And it shows the graph at the bottom there where we used to have the keyboard open. Now, it's a bit hard to see that, so I'm going to resize it. There's the resize button there. By clicking on that, we get it bigger and we can see a little bit more. If you still can't see, just say that your y-intercept was at 23 and your y only goes to a maximum of 10. You would click on that thing there with the arrows, and that takes you to a screen like this. In there, you can change your minimum and maximum y values. So here I've got it listed, minimum x is negative 20, maximum is 20. I've got y minimum is negative 10 and maximum of 10. So in the case that I couldn't see my y-intercept and I knew it was in the positive part of y, I could increase that maximum. I could say 50 or 100 or really anything I like. Once you've done that, you click OK and it will show it. So there's my graph. And now I'm going to go to analysis because in there are some really cool things. Once I click analysis, I get this menu here. Gsolve is what I want. And in Gsolve, I have this list here. So when I click on Gsolve, I get root, max, min, fmax, fmin, y-intercept, etc. To find the x-intercept, it's root. So that's another word for an x-intercept. It's a root. To find your y-intercept, surprise, surprise, you click on y-intercept. by clicking on these things, it immediately will just show you what the y-intercept and the x-intercept are. You don't need to do anything fancy. And that's it.